So these notes are 1.6 notes, and yours should say solving one-step equations. There was a typo on mine, but it's been fixed for your notes. So we have some definitions we're going to talk about first, which is the difference between an expression and an equation. So an expression is numbers and symbols that express a value with no equal sign. So an example of that would be something like 2x plus 3. That's an expression. There's no equal sign. It's got numbers and symbols, and it has no equal sign. An equation is when you have two expressions set equal to each other, so it must have an equal sign. So that's going to look something more like this. So we've got an expression on this side, an expression on this side, and an equal sign in between. So that's an example of what an equation looks like. So you've got an example of an expression, again, numbers and symbols that express a value, no equal sign, so this is very important here. And then our equation is two expressions set equal to each other. So what we're going to learn how today is how to solve these equations. So we need to follow some simple steps. We've got two steps here. Simplify each side of the equation, which means we're going to distribute or combine like terms. If you need to remember how to do that, that was 1.3 notes. If you're forgetting how to distribute or combine like terms, you can review your 1.3 notes. Then we are going to use inverse operations to solve to get the variable alone on one side of the equation. So this is the definition for solving. We want to get that variable alone. We want to isolate it. So when we are thinking of inverses, we know that adding and subtracting are inverses or opposites, right? So inverse means opposite, and multiplying and dividing are opposites of each other's too. So this is just good information to know, and you have them in front of you here while we're working. So we've got some examples in this box down here. We know that addition undoes subtraction, so opposites. These are inverse opposites. Undoes, inverse, opposites, all the same thing. So if you have something like n plus 6 equals negative 13, you need to add 6 on both sides. If you have a negative 6 and a positive 6, they cancel out, and then you can just simplify this side. All that's left over here is n, so that gets pulled down, and you do negative 13 plus 6 to get negative 7. So this is your final answer here. Right? Now, just the opposite, subtraction undoes addition. So if you have an addition starting and you need to undo that, you're going to subtract on both sides. So to do the opposite of adding 3, we must subtract 3. Those will cancel. On the left-hand side, we've got 10 minus 3 equals 7. All that's left over here is x. So that gives us our final answer here of 7. Now, moving into our next bubble, multiplication and division are opposites or inverses of each other. So multiplication undoes division. If you have something, and we've seen some examples like this, or you may have seen some examples like this, we have a divided by 3 equals 12. We need to undo division. Remember, fraction bars are division. So what they're doing is multiplying both sides by 3. Right, so we're multiplying both sides by 3. The multiplied 3 and the dividing 3 cancel each other out. The side's left with a, and over here you did 12 times 3 to get 36. So your answer is 36. And now again, just the opposite. To undo multiplication, you need division. So division undoes multiplication. And remember, the words undoes, inverse, opposites, they're all the same. So maybe we should write those down up here by our notes, right? So we know that inverse is the same as undoes and opposite. Right? So another way to say inverse. So you could hear any of those options. So let's look back at this last example. We have negative 4 times n. Remember how we've talked about how if things are right next to each other, they're being multiplied. So we need to undo that with division. So you divide both sides by negative 4. So these cancel, which is why we do our inverse operations to have them cancel. That leaves us with an n. And over here, you have to do 20 divided by 4, and that gives you negative 5. N is now isolated. It's the only thing on that side of the equation, so we are done. So let's look at some of our own examples here. So example number 1 says negative 3 equals x minus 4. So we want to always move things away from the variable. So in this case, we don't want to move the negative 3. We want to move the subtracting 4. Well, what's the opposite of subtracting? Right up here, we know that addition undoes subtracting. So we are going to add 4 to both sides here. They are going to cancel on this side, which is why we did that. That means that on that side of our equation, all we have left is an x. And now over here, we have to do negative 3 plus 4, which is the same thing as saying 4 minus 3. So that gives us 1. So our final answer to that first example is 1. Now, I want you to try to pause this video for a second and try to do example 2, and then come back in just a second, keep playing the video, and you can see what the answer is. All right, so this example, we have s plus 9 equals 12. We know that subtraction undoes addition, so we want to subtract 9 on both sides here. So a positive 9 and a negative 9 cancel each other out. That's why we did that. We're left with s on the left-hand side. And over here, we've got 12 minus 9, which gives us 3. So that is our final answer. And we know that's our final answer because we have our variable all by itself equals a number. That's how we know that we're done. Let's look at example number 3. We have y divided by 5. So we're not going to say y over 5. We're going to say y divided by 5 because that's what a fraction bar represents, and it will help us get in the mood of saying, or in the mode of saying, that fraction bar is division, so we have to undo that. And to undo division, we need to use multiplication. So we are going to multiply both sides by 5. Multiplication and division are opposites, so these are going to cancel, which is what we want them to do. And we get left with y equals, y is the only thing on the left-hand side. And now on the right-hand side, all we need to do is multiply our two numbers together. 5 times 10 is 50. And now we know that y is equal to 50. Okay, pause that video one more time. Try example number 4, following the example that's right above it, and then replay the video once you have your answer. All right, let's do that last example here. So example number 4 says 24 equals 12 times b, or 12 multiplied by b. So this is multiplication here. We need to undo multiplication, and the example says division undoes multiplication. So we need to divide this side by 12 to get that 12 out of the way. And we're going to divide this side by 12 because whatever you do to one side of the equation, we must do to the other. Dividing and multiplying by 12 cancel. So we're left with b on the right-hand side of the equation. And over here, we've got 24 divided by 12, and that gives us 2. Our variable is isolated. We have it equal to one number, so we must be done. Make sure you watch the second part of the video for the second half of these notes.